it's important to know the different steps of, you need to think about this like an army general. You've got an invader and you've got something coming in, and so if it makes it past this thing, what's the next thing? What's our next barrier? If it makes it past this, how are we going to fight this off? And if it infiltrates our ranks, how are we going to know what it is and how are we going to know how to fight it? So these are things that how you should approach the immune system. And like I said, I don't know how much this is going to be on the AP exam. You may see a few questions from the communication side of this, where how cells communicate with one another. And I think it's really good for explaining that. But I think more importantly for you guys just going forward is like the medical standpoint. Like, how does your body react to situations? What's going on when you go to the doctor, or you go to the doctor, maybe your parents or family, and they're having issues, like being able to understand and have some input on that so that you can help out. Yesterday, we got down to primary and secondary immune response on page 957. It's important that you understand that. Like, so what does first exposure look like? What does second exposure look like? Now, on what day are we on? Day 20? I think on day 20, it was either 19 or 20, I posted the review videos on Schoology, and I also posted an article. The article was an explanation of how the new COVID vaccine works, the one that's supposed to be 90% effective. And y'all can read through it and look at it, but I really wanted you to skip down to the part with about halfway down that shows you how the vaccine works. And it does a really good explanation of, okay, well, here's the vaccine. It's giving you your first exposure. You're not getting COVID. You're getting like a part of the virus. Is basically what they're producing is they're using some of the viral DNA to produce the external pieces of virus, the part on the outside, what we would call the antigen, because then that is used to make antibodies. So, and then it takes you through like 2 or 3 steps. It's a pretty simple breakdown of it, but it gives you a good visual of like what's going on with COVID. So I think, people get the flu every year or get colds, and your body is constantly fighting these infections. So what's going on there? I really hope Monday to be able to show, there's a flu video from Discovery Channel, and it takes you kind of step by step of like what's it look like for the infection at the cellular level, and how is your body responding to it. And it's really just kind of an overview of your concept map, to be honest. So real quick here, let's go back and review over the parts that we've talked about previously on innate immunity, and then we're going to get into these B and T cells and figuring out how they act as a specific response to a particular pathogen. Okay? So, and if you have questions or don't understand something, ask, and I'll try to maybe find a better way. And I don't think we'll ever get to the crash course videos. I don't know if y'all are familiar with crash course. If not, if you just YouTube crash course immune system, there are 3 different videos, and the dude goes fast. So if you know Hank, he's real fast, but he's got really good animations and shows what's going on in each of these processes. So, and it's broken up into 3 different sections. Bozeman's got a video. I always like Bozeman the best. He's not quite as exciting on some of them, but he's got a video that goes through the basics of the immune system, basically stuff we've been talking about, and he also has graphs and pictures and stuff to go along with it. So I know some of y'all, there's so much stuff to wrap your head around, and for me to be honest, I'm kind of lazy as a teacher. I call myself efficient, but it's just another word me saying I'm lazy. For me to make a gigantic concept map or make you make one, I think it's important because this is it's a lot of stuff. Okay, so you people at home too. It's a good way to kind of track your thinking about what's going on. So on my concept map at the top, what's the first step in prevention or barrier when something's trying to invade you? Ashlyn?
Your
skin. So in your skin, you have sweat, which is 3 to 5 pH. Your skin is waterproof. What makes your skin waterproof? What's the protein? Anybody know? Makes up your nails and hair. Keratin, good. So keratin is a protein, and it helps to make it waterproof. It's this barrier defense on the outside, kind of like the moat around the castle or your stakes around the fort or whatever. Sweat, urea, those are, I mean, really sweat's just about like urine, to be honest with you, and its constituents. I told you about the time I had the professor who sweated, it looked like pee. Did I tell you about that? Yeah? Yeah, watch out. A lot of, he's such a nice guy too. I wanted to tell him, but there were only like 6 people in class, and I thought if I wrote an anonymous note, it'd be too easy to narrow it down to. So anyway, if I have anything that's objectionable, or maybe I just smell, maybe you can't figure it out from this far away. So the skin is the first barrier. If it makes it past your skin, Mariah, what's the next thing that's going to help you prevent those pathogens from getting farther in? What's going to catch them? I'm just grooming here while you're waiting. Katie? Yeah, so let's start with the mucus. Well, nose hair, that's a big one. A lot of things we get infected with come in through our noses because that's our primary intake of air. And so nose hairs act like a filter. That's really more for, I mean, viruses and stuff are really small. Probably more for catching debris. Like, if you ever mowed a lawn and it's dry out and it's dusty out, you get a ton of stuff. Your boogers are like, they're black almost. You know what I'm talking about, Katie? So it's preventing a lot of that stuff from getting down in your lungs. I mean, it can catch pathogens as well. And then the mucous membranes. So in any orifice you have that has ways of getting stuff from the outside to the inside of your body. Your, seventh planet, your mouth, your nose, your eyes, those all have mucous membranes. And that mucus is like a sticky substance, so if something gets in there, it gets caught. In your lungs, if you breathe like a flu virus in and you get it down into your lungs and it gets caught in that mucus, so you have these little cells with cilia on the top of them, and there's mucus. So basically it gets caught, stuff can get caught in that mucus, and those cells are like, they're fluttering and they're pushing that mucus up and out. That's why, like, sometimes you have a lot of mucus build up in the back of your throat, you're like hacking. A lot of that's actually come up out of your trachea, where that mucus has been pushing stuff up and out, trying to get it out of your lungs. Saliva, tears, pepsin, mucus, all of those are barriers. Let's see, a lot of those, the saliva, tears, they have an antimicrobial protein called what? What do we call that? That helps to kill bacteria and stuff? Lysozymes, good. So they have a lot of those in the saliva and tears that help to break down stuff that's not supposed to be there. And I want to correct myself. I want to sort of correct myself. Mason said, I said that the other day about, if you toot in someone's face, you can get pink eye. Most of the sites, his dad's, optometrist, and he said that's not the case. And most of the sites that I looked up said that was a myth. Unless you just had like a high bacterial content that came out. So I don't know what kind of toot has to happen for that to occur. But anyway, most of it apparently is methane. Interesting. That makes you wonder though, when you toot and be careful what I say here. When how sometimes it's just like it's just loud and obnoxious, but you can't smell anything, and then other times, like you hear the phrase "silent but deadly," Sarah, where it just smells like the stench of death. Like, I wonder what the different constituents are in those. Is it more or less methane? Are there more bacteria in the ones that are super duper stinky? Like, that's some extra credit that I want you people to look up, because I cannot look that up on the school computer. Okay, so, a funny story. One time we had this teacher over here on the corner, and they were studying genetics, and like your sex chromosomes are like XX or XY. One of the kids asked her what the disease is if you had an extra X. So you know what she Googled? XXX. No. That was a mistake. Do not Google that at home. Okay. If a virus or some type of pathogen gets past that point, let's say a virus infects one of your cells, that cell is going to be like, I'm infected. One, it's going to send out signals to other cells around it, the interferons that say, like if you're in medieval times, Walker, and a dragon attacks your hut, and you're fighting it, and you're going to die. But you're like, you get on the phone with your neighbors over there and be like, hey, I got a dragon attacking me, and I'm going to die. So if you could come and kill me, that'd be great. And also if you could start producing, if you could get out your pitchfork and your shovel and stuff, that might help you out a little bit. So basically the virus is doing, your cells are doing the same thing. They're telling cells around them, hey, there's the virus, start making antiviral proteins to fight this, be aware of what's going on. And also they're like on the phone with the other white blood cells, sending out signals, okay? Hey, I'm infected. You need to come and just destroy me because I'm in a lot of pain here, okay? So normal body cells that are infected, they have these little hands, and they hold up a piece of that virus. And they're like, hey, this is what's infecting me. What do we call those hands? MHC. Call them normal body cells. Ones. So they've got their MHC ones up. They're like, hey, this is what's infecting me. And so other blood cells will come along and be like, okay, I got that. And now I'm going to kill you and eat you. So if we're talking about macrophages or monocytes or any of those kind of like Pac-Man cells that come along and eat stuff that's not supposed to be there, okay? So that's some method of communication when cells start to get infected. You have phagocytic cells and neutrophils and macrophages and monocytes. They're going around and they're eating pathogens that are not supposed to be there. They're non-specific in nature, meaning anything they see that's not supposed to be there, they're gonna go eat it or try to. Now that can be, I say not supposed to be there instead of pathogen, because a lot of times, cells will overreact to things that are not bad, that are not bad for you necessarily like a pathogen, but they're foreign. And so, like for instance, if you get a blood transfusion and that blood doesn't match, then your cells could identify and start attacking it. So that's an issue. We're actually going to go through, and I know you see on the board over there, I got the blood typing chart up. We're going to go through and you guys are going to figure out like what blood can be given to whom and who you can receive from and how it matches up. That's an important part of understanding the immune system. So, and then the last thing on here on nonspecific response, let's say you have a foreign substance like a splinter or a mosquito bite or a cut or a scrape. What response takes place then? You get a pimple, inflammatory response. So in that inflammatory response, what happens? It gets hot, it's swelling, it's painful, and all that's due to increased what?
No, blood flow.
Blood flow. So if you think about, you ever get one of those like pimples that hurts real bad, like in the corner of your nose, you know what I'm talking about? Like right on the cartilage, and like you want to pop it, but gosh, it hurts. So just think about, there's increased blood flow to that area. It's swollen. The pain receptors around that, they're getting pushed against, and they're like, there's something wrong with you. And then you've got all of these white blood cells coming in to fight whatever that infection is in that area. And that becomes a problem. Now, I'm talking about like the big white pimples. You can have blackheads and other stuff that are like mostly sebum, which is like a greasy kind of wax your sebaceous glands produce. So that's a little bit different. Sometimes they can get infected and it can build up. But just in terms of an inflammatory response, any kind of cut, scrape that gets red and swollen, it's because of that inflammatory response. And all of that is caused by a release of what? Histamines from the what kind of cells? Histamines are a chemical signal released by mast cells. You want to hold my hand up, it's like a bow, right? I don't know if she got that, but anyway, she did say mast cells, okay. Let's see, I don't know how that represented a boat, but whatever. So, mast and boat. Now, let's say all of this has happened and these foreign invaders have got in and they've started to infect cells. We've got problems. So those cells, they're sending out signals to other cells around them. Macrophages are coming and grabbing them. But if the pathogen is not killed, turn over to page 962. Then we have to mount a specific immune response. So we're basically at the top of the page there. Antigen first exposure. So a cell is exposed, it gets infected, it's engulfed or eaten by an antigen presenting cell like a macrophage or a monocyte. So like cell got infected, held out its MHC1 hands, the antigen presenting cell came over to it like, hey, I see what's going on. I'm going to have to eat you and, dispose of you. And then it's out looking for specific fighters. And it's going to look for what type of cell specifically? I'm on 962 in the picture.
Helper T cells.
Helper T cells. Now, it can activate other lymphocytes. Lymphocytes are the B and T cells that you hear about a lot. It can activate others, and you can see those pluses out to the side there. But it's looking for helper T cells. Helper T cells are the Mac Daddy like running the show here on this specific immune response. Okay? So you keep that out. Keep looking at 962, and let's look in your notes. Yesterday did we talk about B and T cells any? I can't remember if we got to this part. Let's just go back through. B cells produce what? On part 2 of your notes, about a third of the way down. B or bursa cells produce antibodies. Antibodies are like little protein tongs. I said they look like little Y-shaped proteins, which they do, but the note writer says tongs, which actually makes sense because the end of them, they've got a specific protein shape that is the match for whatever the pathogen is. And so it's specific to grab a hold of whatever. What do we call that little thing on the outside of a foreign substance that triggers an antibody? What do we call that little piece? So if you've got like coronavirus on the outside, there's all these little proteins sticking up. If that triggers an antibody being produced, we call it a antigen. Remember, antigen means antibody generating particle. So, and I say pathogen, let's say Ashlyn back there gets a bad blood transfusion and they give her the wrong blood. Well, there's antigens on the outside of those blood cells that are going to trigger antibody production. So it's not always a pathogen, but that's mostly what we're referring to here, okay? All right, Katie, you got questions?
Yeah, I got lost. Like, I don't know. That didn't make sense to me.
Which part?
Most of it. Starting with the antigen thing.
Starting with what?
Antigens.
Okay, do you know what an antigen is?
Not really.
An antigen is really anything. Mostly we're talking about like on the outside of a cell or a virus or outside of a bacteria, that when like a cell takes a virus in and the virus starts replicating and it's like, oh, this is replicating, that cell will take part of that outside of that virus, which is kind of like the ID part. You got to think of the outside of the cells. What you see, that's how cells identify each other, right? Just like when we see each other, we're looking and we're identifying each other based on our looks on the outside. So a virus or a bacteria or whatever pathogen or blood cell, on the outside of it, it has specific proteins, sugars, stuff that it uses to identify itself. Okay? Are you with me there? So if your body sees a foreign invader, it's going to use that outside part of that virus. Like let's say a cell gets infected, it's going to hold out a piece of that virus, the outside of it. What do we call the things it's holding it out on?
MHCs.
MHC.
Complexes.
Which ones?
One.
Ones. If it's on a normal cell, it's going to hold it up, that little piece of the outside of the virus, and it's going to have one of those macrophages or even one of these B or T cells come over to it and be like, okay, that is what we need to fight. So it's looking for, because like just pretend like, let's say you're running a castle and these invaders have gotten past your outside defenses. You need to know what they look like. So you need like one of those little signs that says, hey, these are the people we're looking for, so that you can go out and specifically attack them. And so An antigen just means any kind of little particle on the outside of something that's foreign that generates the production of an antibody. Okay? We'll keep working on this. All right. So, what do we got? B cells produce antibodies. You can see them over there on the left side of 962. We're going to come back to them in a second. I'm going to skip T cells, skip down to helper T. Helper T, I think, is the most important because these are the primary ones that turn on the B and the cytotoxic T cells. Okay? So I know cytotoxic T cells is another type of T cells, but it's a different type of T cell. It has a different function, so don't confuse them. They're called T cells because they mature in the thymus, but these are two very different cells. Okay? The helper T cells help to turn on the B and cytotoxic T cells. These are the ones, when they get infected, they are rendered useless by, that should be really the HIV, which is human immunodeficiency virus. It says AIDS virus. Well, a virus does cause HIV, which then leads to AIDS, which is the syndrome after you've kind of went downhill. So imagine these helper T cells coordinate all of your specific immune response. And if HIV is able to get in there and infect them and render them useless, then what do most people die from that have HIV? They're not dying from HIV, that virus. They're dying from what? A what?
Another sickness.
Yeah, secondary infection. Could be like flu, pneumonia, something like that that's infected your cells. And there's really no way to fight it off because you don't have helper T cells to go out and attack it and to look for specific things. It's just like once something got past your barrier of defenses, you have no other defenses. And once it's in, then there's not much you can do. And this is why if you go back to the 1980s and read up a little bit, you'll see people getting HIV, they're getting AIDS a year later, and then they were dying. I mean, these were happening like, these people weren't living but 2 or 3 years at the most. And so, and the same thing still happens throughout the world today. There's a lot of people throughout like sub-Saharan Africa that they get HIV in a year or two, they die. Okay? They're dying of a secondary infection because their helper T cells, they're just not working any longer. Okay? So they have no specific immune response. Now, and you contrast that with Magic Johnson. Now, I've been around long enough, and I used to watch basketball enough. In 1992, when Magic Johnson came out and announced that he had HIV. And I know everybody thought he was going to die and not live that long, but apparently he's had access to good antiviral medication where he seems really unaffected by it. And it seems as though now our medicines, if you have access to them and take them and do the other appropriate things, stay healthy, that basically what it does is suppress that virus to the point where it doesn't have a big impact on your life. So you can live a pretty normal life. I don't know exactly what the estimate is for how long it shortens your life now, like if you live in the U.S. and you have access to that medicine, but most people are living a pretty normal long life as long as they take the medicine and try to stay healthy, in all the other ways. Anyway, so helper T cells. You can see here on 962, helper T cells are really important. They're kind of the linchpin of this thing. They're holding everything together in the middle. So if a cell gets infected, a normal body cell gets infected, they'll hold up on their MHC1s, that pathogen. An antigen-presenting cell or a cell that's noticed it's infected will come over. It'll grab that pathogen, okay? It'll probably engulf that cell. Maybe it engulfs that cell and then presents it. And it'll come over to the helper T cells. And it's like, hey, we got a problem. This thing is trying to invade, and it's starting to kill our cells, and we need you to help us out, okay? So, and there's two things the helper T cells are going to initiate. They're going to initiate either the B cells or the cytotoxic T cells. B cells make what? Antibodies. So that's a really important part of the fight here. Cytotoxic T cells, they do something a little bit different. Read that one for us, Mariah.
Which one?
Cytotoxic T.
They're at number 3 or A?
2A.
Okay. These are actually killing
infected cells. Toxic means deadly.
Actually, let's skip on down to, and let's go ahead and talk more about this. Yeah, skip down to number 3 toward the bottom of the page. Read that one for us, Ashlyn.
They are activated by an MHC class 1 or IL-2. They kill infected cells by releasing perforin. These are
Yeah.
protein bullets, essentially. Antibodies mark the pathogen parts for disposal by macrophages.
Macrophages. So, a little bit farther down in the notes, it really talks about what cytotoxic T cells do. Now, if you notice in the book, there's 2 ways that it's activated. It can be activated by the helper T cells, okay? Helper T cells, you see where that plus sign is between it and cytotoxic T cells? Y'all can write this in if you want to. I'd put it on your concept map. The signal that stimulates that cytotoxic T cell activation is called interleukin 2, or for short, IL-2, okay? So that's an activating signal. And then also antigen presenting cells there at the top, they can also activate cytotoxic T cells. They work by releasing interleukin 1, okay? So these are just a class of signal molecules. You got to think in your body, Katie, you get like some throat cells that get infected with the flu. You know, you get like sore throat with it and all the stuff. You may have specific cells that can fight off and kill that flu virus. But there's no telling where in your body system, probably in your lymph system somewhere, where these cells are located. You've got trillions of cells in your body. Think of it like, let's say we had some alien invaders come to Earth, and every person on Earth had a different type of alien that they could kill that was just specific to them. You had to locate the one that was just specific to this type of alien, okay? So if that was the case, what's the best way to communicate all around the world to try to get that fighter here, even if you don't know where they are? What would you do? Anyone? One person in the world can kill those aliens. How would you tell them? Would you go around to every person talking to them?
You call them if you have their number.
Well, I mean, you don't know their number. You don't know where they are.
News.
Okay.
Show it, like show what it looks like.
Okay, maybe, but where? On the news? Maybe on the internet? Maybe, you know, post it somewhere where a lot of people see it. So you would maybe send out a big radio call or a all call to everybody if you had like one of those, you know, text messages we get from the county every now and then. So you would want some kind of mass spread signaling to take place looking for that. And hopefully, at some point, you would find where that individual is that could come off, find that alien invader. And it's kind of similar here where these interleukins are trying to find and activate these specific fighters. There's lots of them. They're spread out all over the place. You've got to find them in order to be able to fight off those pathogens. So let's go back up to the top there. We talked about helper T cells. Humoral immunity. Humors mean what? These are your fluids, so like your blood, your lymphatic system. Most of the fighting here is going to be taking place using antibodies from B cells, because basically what happens is the helper T cells activate the B cells. How do they do that? What would be at that plus right there? What do you think? Same as the other side.
IL-1.
No, we'll skip on down there. Humoral immunity. B cells become mature to plasma cells that make antibodies. B cell activation is initiated by interleukin 2. So coming from helper T cells, interleukin 2 is signaling the B cells and the cytotoxic T cells. So once those B cells are activated, they start cloning, making a bunch of copies, and then they develop into these plasma cells which start secreting antibodies. And if you look in your notes there, they're secreting them at a rate of 2,000 antibodies per second. How many is that in a day, Sarah? The correct answer is a bunch. Yes, a bunch. So that's a lot of antibodies. And keep in mind, they're throwing these out. They're going through the bloodstream. They're going through the lymph. And any time that these antibodies, these little tongue or whatever you want to call them, Y-shaped tongue things that have a specific shape on the outside, That shape is specific to a particular pathogen because you don't want them to be able to grab a hold of anything because otherwise they'd be grabbing cells all over the place. You want them to only grab a hold of a specific particular type of pathogen that's infecting you. And they grab a hold of it. And once you get like a bunch of them around that pathogen, then that pathogen can't do anything. And then a macrophage comes along, Pac-Man, and it comes along and, oh, it's got these antibodies on it. I'm going to grab a hold of them, and then I'm going to eat that pathogen that's rendered useless. Okay? So, cell-mediated immunity. This refers to the use of T cells. So if you have cells that get infected, they're going to produce a lot of viruses. I want to say the flu virus, once the virus gets in a cell, it's producing something like 5,000 viruses per cell. That's a lot of viruses spreading around your body. Y'all can correct me if y'all find any better on the Google. But that's a lot of viruses. So you've got to go around and kill all those infected cells. We're not sending them to rehab or hospital or anything else. We just got to get rid of them, okay? So those cytotoxic, how do they go about doing that? The helper T cells are sending out these cytotoxic T cells. How did they activate them?
Also IL-2.
IL-2, good. And it sends them out, and we already talked about cytotoxic T cells. Cytotoxic T cells are basically running around shooting up infected cells with what? Perforin. And it's these proteins that are basically like lysing the cell open. And as those viruses and stuff spill out, then macrophages, then antibodies get attached to them. Macrophages come along and they eat them. Okay? So really, if you think about the hard part here is just finding these cells that are for these particular pathogens. Once you get to that point and you've made a bunch of copies, then really the fight's almost over because they're going to find them, they're going to kill them, they're going to get rid of them. Mariah, under T helper cells initiate the two types of specific immunity. Read that for us, part A.
T helper connects to the macrophage, displaying an MHC type 2. It is attracted to the macrophage by interleukin 1. This allows the T helper to analyze the antigen so it can tell other lymphocytes what to look for. Means first message between WBCs. First message being, come see what I killed so that you can kill it too.
Yeah, so let's say you have an infected cell. It's sending out these signals, I'm infected. This antigen presenting cell, which would be like a macrophage, I think probably the easiest one to think of, engulfs that infected cell. That macrophage is going to hold out that an outside part of that virus, something that identifies it. What's it going to hold it out on? The antigen presenting cell. What's it going to hold it out on?
MHC1.
1?
2.
What do all white blood cells have?
MHC2.
2s. So it's going to hold it out on its MHC2s. It's going to signal to the helper T cells using interleukin 1. It's going to get him to come over. That helper T cell is going to come up. It's going to dock, and and the macrophage is going to be like, "Hey, this is what's infecting and killing our cells." And the helper T cells, okay, let me grab that, and I'm going to go and I'm going to activate these B and T cytotoxic T cells to help go kill this joker. Okay. So that's how it goes down.
So the antigen presenting cell is a WBC.
Yes, that's going to the antigen presenting cell. So antigen first exposure up there, I would think of that like a cell gets infected and it's presenting some of its virus, or a macrophage sees it's infected and it gets a piece of that virus, and or it finds a virus and consumes it and also holds it out. It could be one or the other. Okay.
What engulfs it?
The antigen presenting cell? That would be like the macrophage. Remember macrophages, I mean, like y'all know Pac-Man, right? That's how I think of them. I mean, it's not quite that simple, but they're going around eating cells that are infected, or they're going around eating pathogens that have already been identified. Okay, so they activate the helper T cells. The T cells use interleukin 2 to activate the cytotoxic T and the B cells. And then the fight is on, okay? Now, both types of lymphocytes undergo clonal selection to make effectors and memory cells. If you look over on page 1, why are they making memory cells?
So that they can fight it again.
Turn to 957. So this goes back to our vaccine. If you look at 957, clonal selection means, you see at the top how you have different B cells that have the different little tongs on the outside of them, the grabbers, the proteins are different. Well, instead of 3, think of like millions of those that have very different specific antigen receptors. And they're spread out all throughout your body. Once your body is able to, your helper T cells are able to find and activate those cells, then when it finds the one that fits on there, that the antigen fits with, it's going to, once it finds it's like, okay, now we start making a bunch of clones. Some of those cells, like B cells, are going to start making antibodies. Some of them are going to be memory cells. Because if you get infected once with something, what's likely to happen?
You're gonna get affected.
Yeah, you're going to see it again. It's going to come back around. So you want plenty of memory cells so this doesn't take as long. And that's where that graph comes into play on 957 at the bottom, where it's a much, much quicker response. Okay? At the bottom of the page here, antibodies, also called immunoglobulins. I mean, the easy way to remember that is they kind of cause things to glob together. They've got these different chains or regions. I don't really know that you need to know all that. It's on page 955 at the bottom there. They get into the process of how those different antigen receptors are made and why we have so many different ones. I'm actually going to come back to this when we get to DNA, and I think it'll make more sense. But the really important part is that outside region where it is specific to the antigen. Okay? All right, let's go to part 3. We need to get through blood typing here in the next 10 minutes. Self-tolerant situations. Your body needs to know what is self and what is not, or it's going to attack itself. Do cells in your body attack themselves? Does that ever happen?
No.
Some people it does. What do we call those diseases? Tell you I hadn't read through part 3.
Allergies.
What? Well, that's one. They're attacking things and can cause bad stuff to happen. Yeah, but that's not really what I was going for. They're called autoimmune diseases. Auto means self. Immune disease means you got a problem with the immune system. That means where your body is attacking its own cells. So something screwed up there, and that's what happens. So we don't want that to happen. So how does your body determine, what is self? It's using those outside identifying markers. We'll go through some of those diseases. We'll have to wait till Monday before we talk about that. But let's talk about blood typing. All right, real quick, get out a blank sheet of paper and try to square it off with 16 squares. You people at home see that? Yeah, pretty much. I know you 3 that are there listening. All right. So, we've got our 4 different blood types up here. A, B, AB, and O. Now, each one of these also have a what? You don't just have O blood, you have what?
Positive or negative?
Positive or negative. Each one of these has a positive or negative, and that's super important. I think it's actually a test question. We're going to talk about it because, ladies, one day when you get pregnant, you'll need to be aware of this depending on your blood type. But right now, let's just focus on these. So that means, like, on cell A, on the outside of it, Katie, there are little molecules. We call them A. I don't know what they look like, but we're molecules that are, we call them A, that identify those blood cells. Okay? If you had a blood type that didn't match up with them, those little molecules on the outside would lead to the production of. If you had one blood type and this blood type didn't match up with you, and you got it from somebody, what would your body produce in response to these molecules on the outside?
Antibodies.
Antibodies. Okay? So that's what we're going to get into. So the first thing you need to do, what antigens go with each blood type? Write that down. What antigens, what identifying markers on the outside that could possibly generate an antibody? I'm going to work quick here. All right, Type A blood. What does it have, Sarah? What antigen on the outside?
I don't know.
All right. Ashlyn? Guess. Walker? Tay? Nobody wants to guess? Hey, genius. Thank you, Katie. I wrote it right here, type A blood. It's got A antigens on the outside of it. That is its identifying marker. Whatever A is, whatever molecule A is, that's its identifying marker. Okay? B would have
B.
genius, Walker. AB would have
A and B.
A and B. Two different ones, but on the outside. And then O would have
Oh.
Wouldn't have
none. Okay? Now, you need to think about, if this is your blood type, if you have blood type A, what antibodies would your body make? And do that for each one of these.
Okay, like antibodies are the one that doesn't want.
Antibodies are the things that fight off or that grab a hold of an antigen and render it useless. That are basically going to cause your body to kill it. Sarah, what do you think for type A blood? What antibodies would you find in type A blood?
B.
What happens if you had A antibodies?
And they're getting rid of A.
You would kill yourself. Yes, literally, because it would attach to all your own blood cells and you would die. Okay. So type B blood would have what antibodies?
A.
AB would have what type of antibodies?
None.
Why?
Because it's already got A and B.
It's got A and B, and if you had A or B antibodies, then you'd have some serious problems. Oh, what antibodies would it have?
A and B.
A and B. Good. All right, so here's where the thinking actually comes into play. If you had A blood, who could you donate to?
A.
Well, I mean, y'all write it down. Let's go see if we can go through these.
Oh.
You have to consider what antibodies that person has. So if you have type A, who could you give blood to? And then take it and be okay. So you have to consider the antigens and the antibodies. Yeah.
So for O, you could give them all. Doesn't that be universal blood type?
Universal blood type or
Like, I mean, like universal, like blood transfusion, like blood type.
donor me.
Yes, donor. That's what I mean.
All right, type A blood. Who could you give blood to?
Type
A and who else?
A. O.
A, B,
No.
What type?
A, B.
Why AB?
Because
Is AB going to fight off your A blood?
No.
No. B, what type of blood can you give to, Sarah?
B.
And?
A. B.
Good, because neither one of those have antibodies that's going to fight you off. AB, who can you give blood to, Walker?
I think only A, B.
All the others have some type of antigen or antibody that would attack you. Oh, who can you give blood to?
All of them.
Why?
Because none of them have O antibodies.
Well, O just means the lack of this antigen. There's no antigen there. And so even if they have these antibodies, it's not going to attack you because you don't have any antigens there for it to latch onto. Does that make sense, Katie?
Yeah.
So O doesn't have them, even if they have these antibodies that are out looking for stuff that's foreign, there's nothing foreign there for them to grab a hold of. It's kind of like, when you commit a bank robbery and, you're trying to get away and you get a weird teaching job and then you burn your fingerprints off just to make sure nobody knows who you are. All right, who can you receive blood from? Let's do this quick. All right, write them down. Hopefully you can figure these out. All right, Tay, if you've got type A blood, who can you get blood from? A and
And I,
if you get blood from AB, what's your blood gonna do? Your B antibodies are gonna grab a hold of these B's and they're gonna cause you some serious problems. What'd you say, Katie? O. Good, because the O, you can get blood from O. It doesn't have any antigens on the outside, so you're not gonna attack it. Walker, type B blood, who can you get blood from?
B and O.
You've got BO. Save that for Walker. All right, let's finish this up real quick. Don't put anything up yet. All right, AB, who can you get blood from?
A, B, and AB.
A, B, AB.
And O.
AB is the universal
Blood receiver.
recipient. O, who can you get blood from?
Only O.
All right, now, why is this important? Well, okay, well, that's important in terms of transfusions. They were killing people left and right in like the 20s and 30s when they figured out how to transfuse blood, and then they figured maybe we're doing something wrong and stuff's not matching up. So they have like a blood test where they check to see how the blood interacts with one another. But the last important thing is the plus and minus. So every blood type is plus or minus based on this RH factor. RH, they discovered it in rhesus monkeys, is why they gave it this RH name. If you've got the antigen, if you've got the RH antigen, you would be considered what blood type? If you're type O blood and you have the RH antigen, you would be O positive. So if you have that antigen, you're positive. If you don't, you're negative. That's where the positive and negative comes into play. Okay? So every one of those blood types can either have the RH or it cannot. I want to say about 85% of people have the RH factor and about 15% don't. Now, why is this important? If you are a woman and you are negative and you have a child that is positive, so your baby's daddy is positive, you are going to start to develop antibodies against that child, okay? Now, during your first pregnancy, it's usually not that big a deal. But if you have another kid and that second kid is also positive, then because you've already had this first response to the first kid, you've already built this response up, you could actually lose the baby because of the antibodies that are made against that positive child. Because it has the antigen. Your body's like, oh, that looks a little weird. I don't know what that is. I don't have that. And it's making these antibodies. So good news, ladies. When you get pregnant, go to the doctor. They do a blood test. They give you a shot called Rogam, I think is the name of it, which basically suppresses the production of those antibodies or renders them useless. I don't know. It's the shot you take so you don't kill that second kid. And I don't know what the likelihood of it dying is, but it's definitely one of the reasons why you go and get tested. Okay? So you want to prevent that reaction to that second child or third or fourth or whatever. Y'all have a good weekend.